In order to solve the log equations, we need to get rid of the log base 2. But because we have two of them, we're going to use the property of log, the product property of logs, which means that if I have two logs that are added together, I can rewrite them as multiplication. So I'm going to have x minus 3 times x plus 1, and that's going to equal to 5. So I'm going to get rid of the log. To get rid of the log base 2 is to do the opposite. So that means I'm going to take this whole thing, the log base 2, to the exponent, and I'm going to have 2 as my base. But what I do to one side, I have to do to the other. So my 2 and log base 2 cancel, so I'm just left with x minus 3 times x plus 1, and that's going to equal to 2 to the 5th, which is 32. So then I'm going to multiply, so I'm going to have x squared plus 1x minus 3x minus 3. I'm going to combine my like terms. So because I do have a quadratic, I know that I'm either going to have to factor or use a quadratic formula. So I'm going to move the 32 to the other side. So I'm going to subtract 32 from both sides. So I'm going to factor. So I need two numbers multiplied together. That gives you x squared. So that gives me x and x. So now I need two numbers multiplied together. That gives you negative 35. So it's going to be 7 and 5. Since it's negative, one of them has to be a negative. The other one has to be a positive. And when we multiply, we need to make sure that we get the middle term. So 5x minus 7x does give me negative 2x. So that checks. So we're going to use the zero product property. X minus 7 equals to 0. X plus 5 equals to 0. So therefore I have x equals to 7 and x equals to negative 5. One of the things that I always have to do is I always have to make sure to check for extraneous solutions. Because notice that I have A, or I have I have B, or I have each of the individual parts. So I'm going to check for extraneous solution. So I'm going to have log base 2 of 7 minus 3 plus log base 2 of 7 plus 1. And what I'm doing is wherever I see an x, I'm just substituting this 7. So I have log base 2 of 4 plus log base 2 of 8. Okay, so as we look at my logs, log base 2 of 4 means what exponent 2 to the what power gives you 4. So that's going to be 2. And then 2 to the what power gives you 8. And notice that that equals to 5. So the 7 checks. So now I'm going to do the negative 5. So log base 2 of negative 5 minus 3 plus log base 2 of negative 5 plus 1. So I have log base 2 of negative 8 plus log base 2 of negative 4. Now, since I have negative 8, what this means is 2 to what power is going to give you negative 8. There's no such number. 2 to whatever power is always going to be positive. Logs or ln's can never be negative, so this would be wrong. So 5 is an extraneous solution, or negative 5. So my only answer is going to be 7. So remember to always check for extraneous solution.